The cosmic U-turn. Is the Big Bounce making a comeback? The ultimate fate of our universe has long been a subject of intense debate. Will it expand forever into a frozen, empty void? Or will it eventually collapse and trigger a new beginning? While the heat-death theory has dominated scientific thought for decades, new data regarding the nature of dark energy is breathing fresh life into an ancient idea. Cyclic cosmology, also known as the Big Bounce. The allure of a cyclic universe, cyclic cosmology, proposes a universe that operates in endless loops. Instead of a single, linear journey from a Big Bang to an eternal end, this model suggests the universe expands, eventually slows down, contracts under the force of gravity, the Big Crunch, and then explodes outward once more in a new Big Bang. For many cosmologists, this model offers an elegant solution to the most difficult questions in physics. The before problem. If the universe is cyclic, we no longer need to explain what happened before. The Big Bang, it was simply the result of the previous cycle. The coincidence problem. As Nobel laureate Adam Riess notes, a cyclic model removes the unbelievable coincidence that we happen to live in a highly specific, life-sustaining era. In a recurring universe, such conditions are bound to happen eventually. Why the theory fell out of favor despite its mathematical beauty, the Big Bounce lost its footing in the late 20th century. The primary culprit was the discovery of dark energy. Observations revealed that the universe isn't just expanding, it is accelerating. This outward push, driven by dark energy, appeared to be far too strong for gravity to ever overcome. For a long time, the consensus was that the universe would succumb to heat death, a state where expansion continues indefinitely until matter decays, stars burn out, and the cosmos becomes a cold, dark, and empty expanse. Furthermore, the theory faced a massive hurdle in the second law of thermodynamics, which states that entropy disorder in a closed system must always increase. If the universe contracts, how does entropy decrease? While theorists like Roger Penrose have proposed complex models, such as conformal cyclic cosmology to account for this, these ideas remain difficult to prove and are viewed with significant skepticism by the broader scientific community. A new variable. The DESI data. The landscape of cosmology is shifting due to new findings from the Dark Energy Spectroscopic Instrument, DESI. By creating the largest 3D map of the universe ever made, DESI has provided a surprising insight. Dark energy may not be a constant force. Recent data suggests that the acceleration of the universe's expansion might be weakening. While this does not mean the universe is currently shrinking, it fundamentally changes our understanding of the cosmic trajectory. What could be causing dark energy to change could mean that in another 10 billion years' time, dark energy weakens so much that it does reverse, and it does pull everything back in on itself, says astronomer Catherine Hamans. The great unknown. While the possibility of a Big Bounce is resurfacing, scientists remain cautious. We are currently grappling with a massive knowledge gap. Dark energy accounts for nearly 70% of the universe, yet we still do not understand what it actually is or how it functions. Without a definitive understanding of dark energy, predicting the long-term future of the cosmos is an exercise in uncertainty. As Adam Riess points out, until we understand the engine driving the expansion, all bets are off. Conclusion. While the heat death remains the leading theory, the possibility that dark energy is weakening opens the door for cyclic models once again. We are entering a new era of cosmology where the Big Bounce is no longer a discarded relic, but a serious contender for the ultimate fate of our universe.